Database normalization. What is database normalization? Normalization is the process that removes any type of error, anomaly, or redundancy that might exist in the design of your tables and in the links between different sources of information. Why do we normalize databases? Reasons include to avoid data being replicated in various tables at the same time or unrelated product data or any data being gathered together in the same table. In addition, this technique makes it possible to make your database more logical and natural, reducing their size and simplifying the structure to make product or make data easier to locate, contrast, and retrieve. However, it's commonly heard among programmers that normalizing data is not a priority task. Is that a complaint or a reality? Certainly, it does require a significant investment of time and effort. Then there's its main disadvantage that normalized databases do slow down processes considerably. That may be true, but it's worthwhile undertaking a process of database normalization in order to avoid other problems that may arise later on. The tasks you avoid doing now will have to be taken care of at some point in the future. Also, it's better to do them while control of your product or databases haven't yet reached an unsustainable level. Objectives of database normalization. It may seem confusing as to what normalization is really for. This is a summary of the objectives of database normalization. So one objective is to correct duplicate data and database anomalies. To avoid creating and updating any unwanted data connections and dependencies. To prevent unwanted deletions of data. And to optimize storage space. To reduce the delay and complexity of checking databases when new types of data need to be introduced, and to facilitate the access and interpretation of data to users and applications that make use of the databases. Types and stages of database normalization. Databases can be classified by their level of normalization. So from level 1 to level 5 or sometimes up to 8 different types are mentioned. This means that level 1, first normal form or 1NF, is the simplest and most basic way of normalizing data. Then it's up to 5NF, or fifth normal form, the most sophisticated. The latter is rarely used and it is more common to see the first three types. So the first three types. 1NF, or the first normal form, removes duplicates and creates separate tables for groups of related data. 2NF, or the second normal form, removes subgroups of data present in multiple rows of a table and creates new tables with connections between them. The third normal form deletes columns that do not depend on the main key value. And the fourth normal form deletes all dependencies between multiple values. The requirements for meeting its level of normalization, expand to include more complex techniques, although this doesn't mean they then improve for all companies. Knowing the type and specific organizational needs of your business is key to choosing the right database normalization process, or even the best combination of rules from different types of normalization. So at a glance, or visually, these are the steps in normalization. So up to the third normal form, as I've said, usually when we normalize, it's only up to the third normal form. The fourth, the fifth, or maybe up to the eighth are actually very rarely used. So first, we have here a table with repeating groups. And then what do? We remove repeating groups. And if we do that, or separate the repeating groups maybe into another table, then we have the first normal form. Then when you are at the first normal form, when you remove partial dependencies, then you achieve the second normal form. And at second normal form, you remove transitive dependencies, then you are now on the third normal form. Now we're talking about dependency. What's dependency or what's functional dependency? So we could say that A is dependent or functionally dependent to B. So a particular relationship between two attributes. For any relationship R, that's a table, attribute B is functionally dependent on A if for every valid instance of A, that value of A uniquely determines the value of B. So again, that value of A uniquely determines the value of B. So here are some examples. The social security number. So if you know the social security number, then with that you can determine the name, the address, and the birth date. So that means that this is dependent on this, or B is functionally dependent on this, or these fields are dependent on this. So ISBN, if we know the ISBN, then we know the title because this is a unique number. So we could say that the title is functionally dependent to ISBN. Now, so first normal form, or 1NF. A relation is in the first normal form, or 1NF, if it contains no repeating data. So repeating group is a set of data items that can occur any number of times in a single record. Converted to relation in 1NF by extending the data in each column to fill cells that are empty and group-related data. So we'll be doing that later in our example. The second normal form, or the 2NF, partial functional dependencies. So exists when one or more non-key attributes are functionally dependent on part. So that's the key word here. Functionally dependent on part, but not all of the primary key. So on just part of the primary key. So to convert a relation to second normal form, we decompose the relation into new relations. So we create a new table using the attributes called determinants that determine other attributes. The determinants become the primary key of the new relation. Then on the third normal form, the relation is in the third normal form, or 3NF, if it is in the second normal form and there are no functional or transitive dependencies between two or more non-primary key attributes. So that's the third normal form. Okay, so that ends the my PowerPoint presentation. Now let's have an example. So here, let's say for example, we have here here is a table, and of course, this will be repeated. I will not repeat it anymore, but we'll know that for a particular sales, we can have several products. So the product number, product description, quantity, and price could be repeated. And I color this red to determine to emphasize that that is the primary key. Okay. So now let's take a look at the steps. So let's go back to my PowerPoint presentation and let's go back to first normal form. Wait. To view slideshow from current slide. So it says here that a relation is the first normal form. It contains no repeating data, repeating group, set of data items that can occur. So convert the relation in 1F by extending the data in its column to fill cells that are empty and group-related data. So that means we have to separate all repeating data. Okay, so again, this is repeated. So what we're going to do, I'll just copy this first. And this one is the repeated data. We have to separate this. Okay? But there should still be a relationship. So we have to place here the primary key. And we're going to call this one now our sales detail. So let's say that's the name of our new relation or new table. Sales detail. But this is not our primary key. Why? Because for one sales number, we can have several sales detail because again, this is coming from, or this could be repeated. So this is not our primary key. nor product number is our primary key. But if we combine both, then it can be unique. So this will be our primary key. So we have a multi-value primary key. Okay. So again, that's a multi-value primary key. Now let's take a look at the second normal forms, because we are now on the first normal form. So let's go back. This is our first normal form. So we have now two relations or two tables. Then our second normal form, so partial functional dependencies exist when one or more non-key attributes are functionally dependent on part but not all of the primary key. So again, if it is not dependent on just both or all of the primary key, then we have to move that into another relation. So let's go back here. So let's take a look at this. So since this is only the table here wherein we have multiple keys. Okay. Now product description is actually dependent on the product number. Quantity is not dependent on the product number. But price can also be dependent on the product number. So if you know the product number, we should know the product description, we should know the price, but not necessarily the quantity. So what we're going to do here now, okay, let's first copy this. So no effect for this one. And sales detail. I'll first copy this. But only quantity is not dependent. So I'm going to place here quantity. And I'm going to place here, this one is dependent on this and this. So I'm going to place so this should be here. We have here product number, product description, and price. And I'm going to place here a new relation or a new table, which I'm going to call products. So, okay. So I have here now three relations in my second normal form. So we have sales, sales detail, and products. So I'm now on my second normal form. What about the third normal form? A relation is in third normal form if it is in second normal form and there are no functional or transitive dependencies between two or more non-primary keys. So we're now looking at dependencies to a non-primary key attribute. Okay, so let's go back to this. Now here, this is a primary key, so date is dependent on that. If you know the sales number, the particular sales number, we know the date, maybe we know the customer. But name is not really dependent on sales number, but it is dependent on customer number. Address is also dependent on customer number, and contact number is also dependent on customer number. So it is these three are dependent on a non-primary key value. And this one is dependent on a primary key, so there's no problem with that. So let's first copy this or copy these three. Okay. And then I'll just copy this because there should be no effect for this one. And now, these three, or these four rather, will form a new relation. And let me call that my customer. So this will be my, and this is my primary key. And that's it. And I'll just copy this table here. So I'll make it smaller. So this is now my third normal form. Okay, so let's have a review. this is our zero normal form, or we haven't done any normalization yet. So again, to achieve the first normal form, we just separate repeated data, but create a link, and then that's it. We have now our first normal form. So we still should be, this one should still be related to this. That's why we have to place a sales number, and both of these should be our primary key. In the second normal form, we're going to look at attributes here that are dependent only on just one of these primary key, not both. So in that case, product description is dependent on number. Quantity is not dependent on product number. It's not dependent on sales number alone, but it should be the combination of sales number and product number. And price is dependent on product number alone. So product description and price was separated here, and we have product number as our primary key. While quantity, since it is dependent on both of these, so it's retained in our sales detail. So that's the second normal form. In the third normal form, we're going to look for fields that are related or dependent on a non-key value. So in this case, we have found name, address, and contact number to be dependent on customer number. That's why what we're going to do is to create a new relation or a new table. So customer number, name, address, and contact number. And here we just have here customer number. So we have to remove that. And then sales details, just okay. And product, just okay. So this is now our third normal form. So that's it. We have now normalized our table. Of course, in actual, we may have several fields or several tables, but these are still the steps we have to follow to normalize our database. So thank you very much for listening to this video.